All right. So 4D.2 is the laws of natural logarithms. I think I'm going to shut the lights off for you so you can see. Okay. So don't forget your stop box. And now after you get that stop box, there's that title again. So one thing we'll see is that these laws are exactly the same as the laws that we have already talked about. So the notes are pretty short since it's so similar to things that we've already done. So the laws of natural logarithms are the logs from logarithms written in base E. So we already talked about the logs in base, I think it was base A or base C, which means it could be any kind of letter or number, any base. So all those laws work the exact same way. So when we want to combine our logs, if we're adding, we know we multiply. If we're subtracting, we divide. If we've got a number out front, we can put that in our logarithm. So all of those are exactly the same, even if it says ln instead of saying log base E. So we will take a look at that and then talk a little bit about the types of questions that you might see. So here are the laws of natural logarithms. So just like last time, A and B do have to be positive, but if I've got the natural log of A plus the natural log of B, and if I want to combine them into one logarithm, it becomes the natural logarithm of A times B. So it works the exact same way because natural logs have the same base. That base is technically E. Keep in mind it does work backwards as well, so if we ever find ourselves in a situation where we need to split up a log in its multiplication, I can change it into the addition of those separate logs. Then we have the law with subtraction. Again, this is the same as those laws we've already had, where I can combine that subtraction and divide what we're taking the logs of. And if I had a division and I wanted to split it up, I would split it up using subtraction. So those are exactly the same. And so is this one, where if we're multiplying our log by some number, I can put that number into my log as a power of whatever I was taking the log of. So that n comes in and I have the natural log of A to the nth power. Now we've been talking about these laws pretty much since Monday. Are there any questions, any concerns about these? Now these ones are not, written in your packet with a natural log, but we know log base C is written in our packet, so we can always look back at that. Okay. Wait, I have one more thing to say, sorry. So you're going to see problems that might be right as a single logarithm or integer. So we've got to take these logs and kind of put them together. And you might have show that problems, which we've talked a lot about. So then you want to make sure you show all of your steps. And then this next set of directions might look a little different. And so that is right in the form ln A, and it's missing a little something. It also will say that A is contained in Q. Okay, that was a terrible Q. I'm fixing that. That's still pretty bad, but I've got A is contained in Q. So I don't want you guys to freak out when you see that, because it's actually, we're going to use the same methods that we would use if we were writing as a single logarithm. Now, you don't have to write these down, but you do have to kind of look back and think about one of those first background knowledge chapters or sections we did where we know that, like, this R, this double barred R means all real numbers. We know that this means natural numbers. We know that that means integers. Well, what does the Q mean? So we have to think back. Maybe look back at our notes from that background knowledge chapter. What does Q? What group of numbers does Q stand for? Pretty much. Okay, so Stephen said fractions, and then Joe came up with the technical term for that. It's rational numbers. So what this means is we're going to combine everything to have a single logarithm, so it's just ln, and then a just has to be a rational number. So that, well, I'll talk about that as we do this example, but that means you don't want exponents on it. You want to evaluate it so that a is just a number, but it can be a fraction because it's rational. So don't panic when you see that. So I've got 5 ln 3 plus ln 4. So I want to be able to put this together. So the first thing I have to do is take that 5 and put it into my log. So remember, then that would be ln of 3 to the 5th power. So if I'm multiplying that log by something, I can bring it into the log by making it an exponent, plus the natural log of 4. Now, you can simplify 3 to the 5th power now if you want to. I'm going to wait till the end, but it really does not matter. Thinking about our laws, if I'm going to put these together to a single logarithm, and that's addition, then I have to multiply the two things that are in my log. So I'm going to have to do 3 to the 5th power times 4. And then this is sort of where that Q comes in, is whatever's in here, like I said, you just want it to be a number. You don't want it to be this expression. So then we'll probably grab a calculator, do 3 to the 5th power, and then times that by 4. I got something different. It's 972.
I meant for 3 to the 5th.
Oh, okay. That makes more sense. That makes much more sense. And that, I think, is accurate, yes. So I did 3 to the 5th power and then times it by 4. But like that, the point is that it is in that form. I have natural log of this number, and this number is rational. So this is not part of our answer, but just showing you it's still in that form because that number is rational. So this could also be a fraction as well. Okay. Now, I can do some more examples. There aren't any other ones on the Prezi. How do you guys feel? Alright, okay. So then if we move on then to your stop box, we'll have plenty of time for you guys to like get caught up on assignments and such. What's your biggest takeaway? I really did struggle with some stop boxes on some of these because this is so much review. Like, this isn't really that new. It's just instead of log plus log equals whatever, it's ln plus ln equals whatever. I don't know, anything you guys take away? Maybe that it's like the same, it's the same stuff. I don't know. Anything that you think sticks out to you? You remember it now? Good. So all you think is doing it over and over again? Cool. Alright, so here is the assignment for, this is 4D.2. Now I know this assignment is not due until Monday, but really make sure that you get caught up on all of your work and ask questions. What does get caught up on all of your work kind of code for? No? Okay. Get caught up on all of your work generally means there's a quiz in your future. It's me trying to warn you.